Okay, so table 2, where do you see the 8 from the equation in the graph?
The y on the slope.
Okay, good. And how do you know that?
It's going through the, you'll see that the eight is through.
Okay, what about from the equation? How do you know that this number represents the y-intercept?
It's goes through, is it the y goes through? It's just first.
Okay, can someone elaborate on that? Because you're correct, but I just need a little bit more, like table 3.
No, it's the one without the x.
Good, so, so this is a straight line, otherwise known as a linear equation in the form y equals mx plus b. It is okay to write it in the order y equals b plus mx. You should still be able to tell the difference between like the y-intercept and the slope, because the y-intercept is always the one without the x, right? Or otherwise known as the constant. Good, so you guys are correct on that. Table 4, where do you see the -2 from the equation in the graph?
I believe that it's the slope of the equation because it's in the spot in the end.
Okay.
M equals.
Okay, good. So where this is located, which is in front of the x, is in the spot of the slope. So slope on a graph or on a linear graph is what over what? Class. Good. So where it is on the graph is in the rise over run. So if it's -2, means we go down 2, and how many to the right? 1. Good. So if it's a whole number, or really an integer is what it is, but make it a fraction, that's your rise over run. So down 2 to the right 1, that's where my slope is. Down 2 to the right 1. Make sure you see how they're numbered. Questions there? All right, so table 5, what's the x-intercept of this graph? 4, good. So that answers that. 4. And table 6, how does this relate to the equation? Sorry, what? Okay, so I mean, you're close. What she said was plugging in the x to solve for y. So think about it this way. Yes, it is. We know it's the x-intercept because it's where it crosses the x-axis, right? So that's easy when you can see it. Do you know how to tell without graphing it? Like how to solve it algebraically? Table 7, do you know? How to solve for the x-intercept algebraically? No. All right, give me some more definitions for x-intercept other than it crosses the x-axis. It is when, no, there's more. Parker?
Y equals 0.
It is when y equals 0. So your x-intercept is when y equals 0, and that's the same for y-intercept, that's when x equals 0. So you could, given your equation, and without graphing, plug in a 0 for the y, and solve for your x-intercept. And I'm telling you right now, it's going to be 4. So, you know, use your inverse operations, isolate the x by starting with what's farther. So -8 equals -2x, opposite of multiplying, -2 is good. So then x does end up equaling 4. So that's why you need to know both definitions. So how it relates to the equation, you could show this work. And also just know that x-intercept is when y equals 0. Okay, questions, comments, concerns? And that's true for any type of function, not just linear. You could plug in zeros for either the x or the y and basically solve for the other, and that's one of your intercepts. All right, so good warm up, scrolling down. So this says revisiting projectile motion. Period 1, you guys will have like that lesson Thursday, but it's really easy actually. So this equation, h of t equals 10 plus 78t minus 16t squared. First, before I keep reading, what type of function is this? Linear, exponential, or quadratic?
It's quadratic.
And why do you think it's quadratic?
There's no multiplication.
Okay, that's a good, so it's definitely not exponential then. It's definitely not linear. Good. So specifically because we have a variable squared. All right, so, and that's like the highest exponent out of all of them. So that's what makes it exponential. If you graphed it, you would get a U shape. And in this situation, it's modeling the height of an object thrown upward from a height of 10 feet with a vertical velocity of 78 feet per second. So I feel like it doesn't really, it may matter that you know this or not, but when you are looking at this equation and reading what it's talking about, where it's thrown from or dropped from, it could be, is like what your constant is, and whatever the vertical velocity is in front of the x for the t to the first. Just so you know, if they ever have to make you make the equation, I think only 1 year that happened to my students. And then it's always, for when it's projectile motion, -16 before the x squared. Just so you know. So this says, is the expression written in standard form? All right, you guys probably don't know that yet because you guys haven't done lesson 8 or 9 yet. So I'll show you what standard form is and you can see. So standard form of quadratic equations, so I would write this down somewhere in a free space, is going to be in the form ax squared plus bx plus c, where a, b, and c are numbers. Okay, so standard form of quadratic equations is ax squared plus bx plus c, and maybe like equal to y or something, maybe equal to f of x, something like that. So discuss in your groups. Is it in standard form? All right, so raise your hand if you think, yes, it is in standard form. Okay, 6 people. Raise your hand if you think, no, it is not in standard form. Okay, so here's what the book says, and I'm sure you might clearly say that it's not in the same order. I agree with you there. The way that they have it written would be like the c plus bx plus ax squared. So I agree with you, it's not in the correct order. But the book says, yes, it is a sum of a squared term, a linear term, and a constant term written in that form. So when it's written in this form, so the answer is yes, if you want to fill that in on your paper. When it's written in this form, what is my value for the a? It is not 10. -16 is correct. So the number that's in front of the number or the variable squared is your A. Just like how you guys know the difference between M and B and Y equals MX plus B. It's okay for it to be out of order. You still need to be able to identify your A, B, and C. Okay, so A is negative 16. What's B?
Say,
78. And what is C? Good. And the signs do matter. The only one that was negative was the A. Question? All right. So then Jada said that the equation G of T equals negative 16T minus 2 in parentheses times the difference of T and 5 also defines the same function written in factored form. So factored form is, so let's kind of pause for a second. Do you guys remember what the word factor means?
a multiple of a number.
Okay, so factors are what you multiply. So when it says that this function are the factors of that function, how could I verify that she's right or not? By multiplying them together. Good. Do you guys know how to multiply two binomials together? I've never taught you it. Unless you're in my math lab. Sorry, what? Ever heard of like the FOIL method? Maybe, anyone? Okay, well. Let me also show them. The FOIL method is a way to multiply two binomials. So say you have A plus B times C plus B. FOIL stands for first, outer, inner, last. So in that case, if I have two binomials, so two two-term expressions multiplied together, I could use this method to multiply them. So if I was using this, A times C is AC. And then you do your outer numbers of each parenthesis. A times B is AB. Then inner, B times C is good, and then last, so the last numbers in each parentheses, B times D is, okay, good. And A, B, C, and D can be any numbers. So I'm gonna have you guys see if Jada is correct by foiling this problem. Now, negative 16T minus 2 parentheses times T minus 5 in parentheses. So now try that method with this. Question? All right, it's okay if you're like slightly confused. I've never taught you this before. This is the first time. So just try it out. Try the first, outer, inner, last, and see what you get. So that, and you guys would know because you would have multiplied it together and seen if it was the same as what we had originally. Who thinks that these are the factors of our given equation? Raise your hand. Okay, who thinks that they are not? Okay, nobody knows. Let's see. So the way you figure that out, if these are factors of the standard form that we were given, is to multiply them together and see if it's the one. So use the FOIL method. Otherwise, you could use another method, but I'll show you that a different day. Both are the same thing in time. So first, outer, inner, last. What are my first two terms in each parentheses? Negative 16T and T, multiply them together. What do we get? Okay, good. Now I'm gonna go table by table. So by the graphs, what we're talking about. Table 8. What are my outer terms in each parenthesis? No, T would be considered inner because it's more like on the inside of the problem. No, -2 is also inner. So if these two are both the inner, then,
Oh, or it would be different one.
and,
Um,
okay, good. So these are what we multiply together next. They're physically on the outside. It goes FOIL, first outer inner last. So outer terms, I don't know what -16 times -5 is. Can you guys do that for me? I know it's definitely a positive. It's 8. Okay, let's see. So let me just verify because I was doing this for the first time. So it would be a positive 80, and then this T didn't magically go away, so make sure it's 80T. Do we have questions so far? Okay. Now we have to multiply the inner terms. So table 9, what are my inner terms?
-2, or -2 and 2.
And what's -2 times T?
-2.
Okay, good. Now let's rotate the recorder one to the left, okay? 'Cause now we're back to the front. Or I guess you guys never mix them up. Okay, well, pick one of you. Doesn't really matter. Whoever can tell me from table 1 what the last terms in each parentheses are. And when I multiply them, what do I get? Okay, good. So anyone confused on the first outer inner last? I can try explaining it a different way. Okay. I mean, you could always YouTube the video and I'm sure there's millions of examples out there. But yeah, so this is what we have so far. Is that my fully simplified expression? What can I do to fully simplify it? Good, combine your like terms. I have 2 terms that have the same variable to the same exponent. That's what like terms means. So we can combine them. What's 80T minus 2T? Good, and it's positive, so put plus 78T. Bring down the other stuff that does not have any like terms. And is this equivalent to the standard form expression we were given? It is. So the answer to number 2 is yes. Really, it said show that she is correct, so we kind of knew she was correct. But that is how you can show it, by doing the FOIL method, and showing that, yes, these are factors, because when you multiply them together, you get the standard form. So then, questions on that? Are we good? Okay. So here's a graph representing both the functions. Why does it look like there's only one graph line? Or one line graph? Because they're exactly the same, they would be right on top of each other, right? So that's another way you can tell that she's correct, is if you graph both of them, if they're right on top of each other. Identify or approximate the X and Y intercepts. So vertical and horizontal, hopefully you know which is which. And what do each of these points mean in a situation where they're throwing something? So answer number 3 now with your first. So when it says vertical intercept, which intercept is it talking about?
The Y.
Okay, great. So, because guess what? Y is your vertical axis. So table 3, what is my vertical intercept? Bonus if you can write it in coordinate form.
Oh. Wait, no, hang on, hang on.
Okay, can you tell me a definition for y-intercept? When the x is 0, so there's two ways you can solve it. You could look at the graph at the y-axis, because that's where x would be 0, right? And where does it look like it crosses? 10. So my vertical intercept is 0, 10, because that's when x is 0. You could also plug it into the given equation. Plug in 0 for the x or the t. And guess what? 78 times 0 is 0. Negative 16 times 0 squared is 0. So it ends up just being the 10. Make sense? So in other words, for these, it's 0, c when it's in standard form. Question? Table 3 then. What does horizontal intercept mean? When the y is 0. So table 4, what is my horizontal intercept? It is 5. So that would be in coordinate form 5, 0, because that one it's when the y is 0. That one I would probably look off the graph because it'd kind of be a pain in the butt to solve it the other way. So you plug it into the y. So questions on that? All right. Pay attention. Don't talk over my recordings. Now what it means. So in this situation, we're modeling the height of an object thrown upward from a height of 10 feet and blah, blah, blah. So then table 5, what does the y-intercept represent then?
Starting point.
So starting point, good, because that's what y-intercept usually means. So the starting point when it is thrown. It was thrown from a height of 10 feet. Or yeah, it was 10 feet. So that means my y-axis is feet. What would I label my x-axis, class?
Time.
Time. And do you know what the time frame is?
Probably seconds.
Probably seconds. I don't think it would be up in the air for so that's a good assumption, even though it doesn't say it. So then what does it mean for the x-intercept, table 6? Okay, good. If you didn't hear that, for the x-intercept, so at 5 seconds is when, and I think it's a ball that we're talking about. Let's see. It just says an object. At 5 seconds is when the object hits the ground. That makes sense? Questions, comments, concerns? Okay, because if it's 0 feet off the ground, that must be the ground. All right, makes sense. Everyone good? All right, so let's see. If you're still writing, write faster. X-intercept is when it hits the ground. Y-intercept is where it was thrown from. You can draw a little person if you want, that helps. All right, here's an expression that models function P, another quadratic function. Predict the x-intercept and y-intercept of the graph that represents this function. Looking at it, is this in factored form or standard form? Well, let me remind you, what does standard form look like? Does it look like that? So that must be my factored form then. Okay, it's not necessarily making me convert it to standard form this time. It's saying predict the x-intercept and y-intercept. So how do you figure that out? I'll let you decide. Predict the x and y intercepts that represent this function. All right, what does the word predict mean?
Yes.
Yes, in a way. Any guesses for what the x-intercepts are? You're allowed to be wrong in your predictions, literally nothing. Not even a guess. What about y-intercepts? Okay. Don't even want to give me a prediction. Well, let's see if anyone thought of one. I know it because I've taught this several years. But I haven't taught you the stuff to get to that point. But maybe you'll see it once we graph it. So x minus 9 in parentheses times x minus 1. That could be one way you figured it out. X-intercepts is where it crosses what axes? Okay, good. So you can hover over it. My x-intercepts are 1 and 9, and I'll write it in coordinate form over here. Can you see where those numbers might have come from? The 1 and the 9 from this given equation? Yeah, because what's the definition of x-intercept? When y is 0. So if I made this equal to y, and then of course made that y equal to 0, and solved for the x's. Now these are being multiplied together. Not sure if I'm supposed to take you this far into it, but I'll take you there anyway. These are supposed to be multiplied together. We don't necessarily know what x is. I mean, we know now. But if this is supposed to equal 0, that means one of these parentheses must equal what? 0. Because anything times 0 is 0. So I could essentially set each parentheses equal to 0 and then solve for something that could give me 0 when I plug it in for the x. So then isolate the x. Opposite of subtracting 9 is good. Whatever you do on one side of the equal sign, do to the other side. I get x equals 9, which look is one of my x-intercepts. Whoa. For this one, opposite of subtracting 1 is good. Do it to both sides, and I get x equals 1. Now, you can probably figure it out without necessarily having to write it all out. Think what minus 9 gives me 0. Well, it's not. What minus 1 gives me 1, or 0 gives me 1. Now look at your graph. What is my y-intercept? It is 9. The definition of y-intercept is when the x is 0. So if you plug in 0 for the x's, and there's 2 x's, so make sure you plug it into both of them. What's 0 minus 9? And 0 minus 1. Multiply them together, what do we get? A positive 9. And this is all stuff that we did with linear functions, if you remember. The definition of y-intercept is when x is 0. Definition of x-intercept is when y is 0, and that works for any function. So questions on that? All right. So we'll try to make this quick because I do want to give you some time to practice. Here are pairs of expressions in standard and factored forms. Each pair of expressions define the same quadratic function, which could be represented with a given graph. you're gonna do your best to identify the X and Y intercepts of each graph. So here they are. You're given graphs, find the X and Y intercepts. When you're done, I'll know that you're done and ready to review the answers when you open up your Chromebook and access your puzzle piece for lesson 10. If you look for this video later, it'll be in Friday's slideshow, so that's when everyone else. Wait, hold on. Is anyone at table? Table 4, for function f, this one, what are my x intercepts?
Well, you don't want to make it. Oh, no.
Pass, agree, disagree? Okay, I wrote them normal, but you can write them in coordinate form. That's really good practice. And then you really remember that the y is 0 when it's your x intercept. Okay, good. Table 5. What is my y intercept for function f? That's one of these three. Alex, Jordan, Donovan, y intercept. Or not quite hitting the floor on the y-axis. Try again. Okay, we'll come back to table 5. Make sure you're ready. Table 6. What is my x-intercept for function g? 1. Okay, good. Table 7. What's my y-intercept for function g?
The excellent are ones, is -1.
No. Look at this one, the one that my mouse is on. Function g.
4.
Okay, just 4. And in the coordinate form, it goes 0, 4, because it's when the x is 0. Table 8, function h. What are my x-intercepts for function h? Guys, you shouldn't need to get the answer from someone else. Look at it. Where does it cross the x-axis? 3 is one of them, and okay, I don't know why you're mouthing it to me though. All right, table 9. What about the y-intercept? -9, and in coordinate form, it goes 0, -9. So then back to you, table 5. Y-intercept is what? For function f. Table 5, don't just ignore me. I gave you time to think about it. What's my y-intercept? Where does it cross on the y-axis? Where is the x0 at? Jordan, what is it? What's my y-intercept? Questions on this side before I scroll down? Okay. Back to table 1. So table one, what are my x-intercepts? Okay, good, sorry. I was trying to write it in front of me. Okay, good. Table two, what is my y-intercept for this one? Yeah, okay, good. Questions on that one? So yes, it can be both. If it crosses through the coordinates, it can be both an x and a y-intercept. Table three, what about function j? What are my x-intercepts?
0, 5.
Okay, good. Table four, what about my y-intercept for this one? Good. Table five, x-intercepts for function k. So, table five, Jordan, Donovan, Alex, Gianna, what are my x-intercepts for function k? -2. Sorry, I think I wrote up here, I wrote it wrong. Let me fix it. It goes 5, 0 for the S. On that one. And with this one, it's 5, 0. No one corrected me on that. All right, then table 6, what's my y-intercept for function k? 4. All right, so in that one, there just happened to be one x-intercept. Are we noticing patterns? In the equation, in the way it's set up, hopefully you are. If not, it'll probably be explored in lesson 11. So make sure you do your practice.